Hey guys, Mrs. Patton here. Good Monday morning, March the 30th, 2020. This is your lesson for today. We're going to be talking about Dalton's law of partial pressures and gas stoichiometry. So make sure you have your digital notebook pulled up. You can merge your apps if you don't have more than one device, and you can fill in your notes as you listen to the video. Thank you for being here. Okay guys, feel free to pause the video at any time if you need extra time to write something down or type. But the definition for Dalton's law of partial pressure, it says that the total pressure of a mixture of gases is equal to the sum of the partial pressures of the component gases. The equation for Dalton's law says that P total, or the total pressure, is equal to the pressure of gas 1 plus the pressure of gas 2 plus the pressure of gas 3, and so on. So in other words, the total is equal to all the pieces put together. Okay, so our first example, we have a container with oxygen whose pressure is 159 millimeters of mercury, and we're going to add that to some nitrogen whose pressure is 593 millimeters of mercury for a total combined pressure of 752 millimeters of mercury. And you can also notice in the pictures, we have oxygen by itself, it's blue, plus nitrogen, yellow, and then blue and yellow, nitrogen and oxygen combined. Okay, example 2. The air we breathe is a mixture of oxygen, nitrogen, and various other gases, and has a pressure of 760 millimeters of mercury at sea level. The partial pressure of oxygen is 160 millimeters of mercury, and the partial pressure of nitrogen is 593 millimeters of mercury. What is the pressure of the various other gases? Okay, so they're telling us that the pressure total equals 760 millimeters of mercury. Oxygen is 160 millimeters of mercury. And, so plus, we're going to add that to, so we're adding that to 593 millimeters of mercury for nitrogen. And that's for a total of 753 millimeters of mercury. So oxygen plus nitrogen is 753. Okay, so we're going to take our total pressure, 760, minus the oxygen and nitrogen together to find our various other gases have a pressure of 7 millimeters of mercury. So our missing piece was 7 millimeters of mercury. Gas stoichiometry. Avogadro's law states that 1 mole of gas takes up 22.4 liters of volume. What if we have 4 moles of gas? How much volume would that take up? Well, 4 times 22.4 liters equals 89.6 liters of volume. So 4 moles of gas takes up 89.6 liters of volume. Okay, so gas stoichiometry, example number 1. If we start the following reaction with 17.5 grams of nitrogen gas, how many liters of ammonia will be produced? Now we haven't seen each other in a while, so we have to go over some general rules. Moles equals coefficient. Grams equals go to the periodic table. And you may have a copy in your photos from when I passed it out in class, or you can look one up. Liters equals, this is the new one, liters equals coefficient times 22.4. Okay, so don't forget, things from the question go on top of the equation. So I have 17.5 grams of nitrogen gas. So I found nitrogen, 17.5 grams. Grams on top is grams on bottom. How many liters, so X, of ammonia will be produced? So here's my ammonia, X liters. Liters on top is liters on the bottom. For our bottom numbers, we're going to use the rules we wrote off to the right. So my grams, I'm going to go to my periodic table. The mass of 2 nitrogens, so what's on the periodic table times 2, is 28.014. For my liters, coefficient times 22.4. So 2 times 22.4 equals 44.8. Here's my proportion. So here's my proportion. I'm just going to write it down at the bottom, make it a little bit neater. So I have 17.5 over 28.014 equals X over 44.8. If I cross multiply and divide, X equals 27.99 liters of ammonia. Gas Stoich example number 2. If we start this reaction with 11.2 liters of oxygen gas, how many grams of water will be produced? Okay, so I have 11.2 liters of oxygen gas. So that's going to go over the oxygen. Liters on top, liters on bottom. How many grams of water? So that's my X grams of water. Grams on top is grams on bottom. Now think about your rules for the bottom numbers. Okay, so there's not really a coefficient in front of the oxygen, so that means I have a 1 there. So for liters, 1 times 22.4 is 22.4. Grams, I'm going to go to my periodic table. So my hydrogen, that's 1.008, but I have 2 of them, for a total of 2.016. My oxygen, the mass, so 15.999 grams. Add that all together, 18.015. But there's a coefficient of 2, so we have 2 of these, so times 2 is 36.03 grams. Now we have our proportion. Okay, so we have our proportion, 11.2 over 22.4 equals X over 36.03. Cross multiply and divide, X equals 18.015 grams of water. Okay, so that wraps up your notes for today. Make sure you have filled them out in the digital notebook. You will turn this in at the end of the week. There's one more slide to fill in. Talk to me about one positive thing that has happened since we saw each other in class. Feel free to get creative and add pictures, color, or change the fonts. Have fun with this slide. Tell me something good that's going on. I love you guys. Be safe.